Hello. How's everyone doing today? Okay, so I'm gonna be learning C++ this stream. Actually, learning C++. Last stream was like setting up Visual Studio, but I might delete my previous stream because there wasn't much like actual coding in it. So I think the ads in the Learn C++ website it makes the loading really slow. It makes the entire site slow. So that's one hurdle. That's one problem I will have to go through. Let me just set up my chat and then I will actually start the stream. Okay, I'm visiting learncplus.com and there are a lot of ads. I could use an ad blocker, but I don't like using ad blocker. I try to avoid using ad blockers. Okay, it's not responding now. Hmm. Okay, so last stream I read all of this and I think I would revise some of the topics. Revise introduction to C++ development from there on, all the way till chapter 1. I'm hoping to do some of these chapters in this stream. So, okay, before we can write and execute our first C++ program, we need to understand in more detail how C++ programs get developed. Here is a graphic outlining a simplistic approach. So we did this last stream. Define the problem to solve, design a solution, write a program that implements the solution, compile the program, link object files, test program, and then debug as well. So step 1, this is the what step, where you figure out what the problem is you are intending to solve. Coming up with the initial idea for what you would like to program can be the easiest step or the hardest, but conceptually it is the simplest. Okay, determine how you're going to solve the problem. The how step is where you determine how you're going to solve the problem you came up with. It is also the step that is most neglected in software development. The crux of the issue is that there are many ways to solve a problem. However, some of these solutions are good and some of them are bad. Too often, a programmer will get an idea, sit down, and immediately start coding a solution. This often generates a solution that falls into the bad category. Typically, good solutions have the following characteristics. They're straightforward, well documented, build modularity, so parts can be reused or changed later without impacting other parts of the program. They can recover gracefully or give useful error messages when something unexpected happens. When you sit down and start coding right away, you typically think, I want to do something. So you implement the solution that gets you there the fastest. This can lead the programs that are fragile, hard to change or extend later, or have a lot of bugs. A bug is any kind of programming error that prevents the program from operating correctly. Okay, let's start making notes as well. Mm, yeah. Does Excalibur allow bold fonts? Okay, I don't think they do. Okay. Um, right. I'm just fixing some things. Okay. Various studies have shown that on complex software systems, only 10 to 40% of a programmer's time is actually spent with writing the initial program. The other 60 to 90% is spent on maintenance, which can consist of debugging, updates to cope with changes in the environment, enhancement, or internal improvements. Step 3 is write a program. In order to write the program, we first need two things. First, we need the knowledge of the programming language. That's what these tutorials are for. Second, we need a text editor to write and save our C++ program. The set of C++ instructions that we input into the text editor is called the program's source code, often shortened to just code. It's also possible to write a program using any text editor you want, even something as simple as Windows Notepad. I think I will write this here. Okay, they are talking about editors. Because source code is written using ASCII characters, programming languages use a certain amount of ASCII art to represent mathematical concepts. For example, not assigning is not a part of ASCII character set, so the programming languages typically use explanation equal to represent mathematical inequality instead. I mean, this is more like not assign, not, oh yeah, this is like not equal. Sorry, I got confused for a second. Okay. Chapter, wait, hold on. Next chapter is about compilers, linkers, and stuff. I think I will read about compilers and linkers, and then uh, wait. Yeah, I will read two more introductory chapters, and then I'll go to chapter one. It's loading really slowly. Okay. So step 4, compiling your source code. In order to compile C++ source code files, we use a C++ compiler. The compiler sequentially goes through each source code.cpp file in your program and does two important tasks. First, the compiler checks your C++ code to make sure it follows the rules of the C++ language. Second, the compiler translates your C++ code into machine language instructions. These instructions are stored in an intermediate file called an object file. The object file also contains other data that is required or useful in subsequent set. Okay, I will grab these. Whoops. And take this. Uh, uh, and then write it like the compiler also translates. Okay. Object files are typically named name.o or name.object, where name is the same name as a CPP file it was produced from. C++ compilers are available for many different operating systems. We will discuss installing a compiler shortly, so there is no need to do so now. Linking object files and library. After the compiler has successfully finished, another program called the linker kicks in. The linker's job is to combine all the object files and produce the desired output file, such as an executable file that you can run. The process is called linking. Okay, so we have this. So we have object file, then exe file. First, the linker reads each of the object files generated by the compiler and makes sure they are valid. Second, the linker ensures all cross-file dependencies are resolved properly. For example, if you define something in one CPP file and then use it in a different CPP file, the linker connects the two together. If the linker is unable to connect a reference to something with its definition, you will get a linker error. The linking process will abort. Third, the linker also is capable of linking library files. A library file is a collection of pre-compiled code that has been packaged up for reuse in other programs. Okay, so you have object and libraries, and then it creates a exe file. Because there are multiple steps involved, the term building is often used to refer to the full process. A specific executable produced as a result of building is sometimes called a build. Okay, then IDEs, and then should I read? I was thinking of reading these two first. Hold on. Actually, I'm looking at it now. I think I will just go to chapter 1 directly. Okay, there are so many ads here, and it's stuck in not responding. Okay. Um, in this chapter, we will take a first look at a number of topics that are essential to every C++ program. Because there are quite a few topics to cover, we will cover most at a fairly shallow level. The goal of this chapter is to help you understand how basic C++ programs are constructed. So statements. A computer program is a sequence of instructions that tell the computer what to do. A statement is a type of instruction that causes the program to perform some action. Okay, so this is a definition of statement. There are many different kinds of statements in C++. Declaration statements, jump, expression, compound, selection, iteration, try blocks. I think if you know some programming, it would be familiar for you. Uh, every C++ program must have a special function named main, all lowercase letters. When the program is run, the statements inside of the main are executed in sequential order. Programs typically terminate after the last statement inside function main has been executed. Functions are typically written to do a specific job or perform some useful action. For example, a function named max might contain statements that figures out which of the two numbers is larger. A function named calculate grade might calculate a student's grade from a set of test scores. Okay, so this is the important part. Nomenclature. When discussing functions, it's fairly common shorthand to append a pair of parentheses to the end of the function's name. For example, if you see the term main or do something, this is shorthand for functions named main or do something respectively. This helps differentiate functions from other things with names such as variable without having to write the word function each time. In programming, the name of a function is called its identifier. So dissecting hello world. Line 1 is a special type of line called a preprocessor directive. This include preprocessor directive indicates that we would like to use the contents of the IOStream library. Okay, so this is coming from this. We need this line in order to use std cout on line 5. So std is like standard library. Excluding this line would result in a compile error on line 5, as the compiler wouldn't otherwise know what std cout is. Line 2 is blank and ignored by the compiler. Line 3 tells the compiler we are going to write a function whose name is main. I don't like this. I like it when the semicolon is like over here. Line 4 and 7 tells the compiler which lines are part of the main function, and line 5 is the first statement within function main. So this std cout, which stands for character output, and the this operator, I don't know what you call this, allows us to display information on the console. In this case, we are displaying the text hello world. This statement creates the visible output of the program. Line 6 is a return statement. When an executable program finishes running, the program sends a value back to the operating system in order to indicate whether it ran successfully or not. This particular return statement returns the integer value 0 to the operating system, which means everything went okay. This is the last statement in the program that executes. If parts of the or all of the above explanation are confusing, that's to be expected at this point. This was just to provide a quick overview. Subsequent lessons will dig into all of the above topics with plenty of additional explanation and example. In English, sentences are constructed according to a specific grammar rule. According to specific grammar rules that you probably learned in English class. The rules that govern how sentences are constructed in a language is called syntax. C++ has syntax too. Rules about how your programs must be constructed in order to be considered valid. I'm reading it wrong. When you compile your program, the compiler is responsible for making sure your program follows the basic syntax of the C++ language. If you violate a rule, the compiler will complain when you try to compile your program and issue you a syntax error. So over here, the syntax error is the semicolon. Syntax errors are common when writing a program. Fortunately, they are typically straightforward to find and fix, as the compiler will generally point you right at them. So quiz time. The following quiz is meant to reinforce your understanding of the material presented above. A statement is an instruction in a computer program that tells the computer to perform an action. A function is a collection of statements that execute sequentially. Main, sure. What happens when the program is run? Statements inside main are executed in sequential order. Semicolon. A syntax error is a compiler error that occurs at compile time when your program violates the grammar rules of the C++ language. A library file is a collection of pre-compiled code that has been packaged up for reuse in other programs. The C++ standard library is a library that ships with C++. It contains additional functionality to use in your program. Okay, next chapter. Hold on. Okay, wait. Okay. Uh, a comment is a programmer readable node that is inserted directly into the source code of the program. Comments are ignored by the compiler and are for the programmer's use only. In C++, there are two different styles of comments, both of which serve the same purpose: to help programmers document the code in some way. The / symbol begins a C++ single line comment. So everything from here to the end of the line is ignored. Right. Okay. In this tutorial series, our example fall into one of the following categories: full programs, those with a main function. These are ready to be compiled and run. Snippets, such as the statement above. Multi-line comment, a slash and a star and a backslash. So multi-line comments cannot be nested. Don't use multi-line comments inside other multi-line comments. Wrapping single-line comments inside a multi-line comment is okay. Proper use of comments. Typically, comments should be used for three things. First, for a given library, program, or function, comments are best used to describe what the library, program, or function does. These are typically placed at the top of the file or library or immediately preceding the function. For example, this program calculates the student's final grade based on their test and homework scores. All these comments give the reader a good idea of what the library, program, or function is trying to accomplish without having to look at the actual code. Second, within a library program or function described above, comments can be used to describe how the code is going to accomplish its goal. Okay, I see. Think I can just skip this chapter. Comment your code liberally and write your comments as if speaking to someone who has no idea what the code does. Don't assume you will remember why you made specific choices. Okay. Commenting out code is a common thing to do while developing. So many IDEs provide support for commenting out a highlighted section of code. For Visual Studio's edit menu advanced. Okay, I'll just check that when I'm using Visual Studios. Next lesson, Introduction to Objects and Variables. Is this readable? I hope it is. Because I checked my stream, it was slightly blurry. I'm using font size 11. And also I still haven't figured out this big gap in my line numbering. So if anyone knows, I would really appreciate it. Hold on. I'm refreshing the page because there's some issue. Okay. In lesson 1.1, you learn the majority of the instructions in a program are statements, and that functions are a group of statements that execute sequentially. The statements inside the function perform actions that hopefully generate whatever result the program was designed to produce. But how do programs actually produce result? They do so by manipulating data. In computing, data is any type of information that can be moved, processed, or stored by a computer. Okay. Did we write a definition of a program? Nope. Programs are a collection of instructions that manipulate data to produce a desired result. Computer programs are technically data too, since they can be moved, processed, and stored. However, in the context of a computer program, we typically use the term code to mean the program itself and data to mean the information that the program works with to produce a result. A program can acquire data to work with in many ways, from a file or database over a network, from the user providing input on a keyboard. A single piece of data is called a value. Okay, let's just save that. Common examples of values include letters, numbers, and text. The main memory in a computer is called a random access memory, often called RAM for short. When we run a program, the operating system loads the program into RAM. Any data that is hard-coded into the program itself is loaded at this point. The operating system also reserves some additional RAM for the program to use while it is running. Common uses for this memory is to store values entered by the user, to store data right from a file or network, or to store values calculated while the program is running. You can think of RAM as a series of numbered boxes that can be used to store data while the program is running. In some older programming languages, you could directly access these boxes. You could write a statement to go get the value stored in membox number 7532. In C++, direct memory access is discouraged. Instead, we access memory indirectly through an object. An object represents a region of storage, typically RAM or CPU register that can hold a value. Objects also have associated properties that we will cover in future lessons. Mm, mm. Think I will write this. And this. Is an object like an encapsulation of functions and variables? An encapsulation of related functions and variables. No, that's class. And then an object is like a template for a class. I mean, a class is a template for an object. Although objects in C++ can be unnamed, more often we name our objects using an identifier. An object with a name is called a variable. An object is used to store a value in memory. A variable is an object that has a name. Wait, I'm getting confused by the definition of object over here. In general programming, the term object typically refers to an unnamed object in memory, a variable or a function. In C++, the term object has a narrow definition that excludes functions. When we use the term object in this tutorial, this narrower C++ definition is the one we mean. In order to use a variable in our program, we need to tell the compiler that we want one. The most common way to do this is by use of a special kind of declaration statement called a definition. A definition statement can be used to tell a compiler that we want to use a variable in our program. Okay, I'm getting a little confused, but hopefully it will be clear. Here's an example of defining a variable named x. Define a variable named x of type int. At compile time, when encountering this statement, the compiler makes a note to itself that we want a variable with the name x. Okay. And then the variable has the data type int. From that point forward, whenever we use the identifier x in our code, the compiler will know that we are referring to this variable. So this is a definition, right? No. Yeah. No way, this is a declaration. Okay, they said that they will clarify it later. The compiler handles all of the other details about this variable for us, including determining how much memory the object will need, in what kind of storage the object will be placed, where it will be placed relative to other objects, when it will be created and destroyed. A variable created via a definition statement is said to be defined at the point where the definition statement is placed. For now, your variable should be defined inside functions, such as within main. Okay. Variable creation at runtime. Each object is given an actual storage location, such as RAM or a CPU register, that it can use to store values. The process of reserving storage for an object's use is called allocation. Okay, I'm getting confused by the definition of object. Because in Python or Java, you think of object as an encapsulation of, as an instance of a class. So a stuff that has like fields and functions, fields and methods. But over here, they're referring to, they're basically saying an object is an unnamed variable. A variable is a named object. An object is any region of storage. So far, we have covered that objects are regions of storage that can store a data value. A data type, commonly just called a type, determines what kind of value the object will store. In the above example, our variable x was given type int, which means variable x will store an integer value. An integer is a number that can be written without a fractional component. 4, 27, 0, minus 2, minus 12. For short, we can say that x is an integer variable. In C++, the type of an object must be known at compile time. And that type cannot be changed without recompiling the program. This means an integer variable can hold integer values. If you want to store some other kind of value, you will need to use a different type. A data type of an object must be known at compile time. Integers are just one of many types of C++, one of many types that C++ supports out of the box. For illustrative purposes, here's another example defining a variable using data type double. So double with defining multiple variables. It is possible to define multiple variables of the same type in a single statement separated by separating the names with a comma. The following two snippets of the codes are effectively the same. Okay, so this are the same thing. This is not correct. This is correct. Okay, so if it's different, we have to separate them. Although the language allows you to do so, defining multiple variables of the same type in a single statement, avoid defining multiple variables of the same type in a single statement. In C++, we use objects to access memory. A named object is called a variable. Each variable has an identifier type and a value. Variables are actually created at runtime when memory is allocated for their use. So data is any type of information that can be moved, processed, or stored by a computer. Value is a letter, number, or text, or instant of some other useful component that can be represented as data. An object is a piece of storage, a region of storage that can store a value. Variable is a named object. Identifier is what you use to identify the variable. Data type determines what kind of value the object will store. An integer is a whole, a number without a fractional component. So variable assignments and initialization.